there, my name is Shelley. In this series of maths lessons, we will cover algebraic fractions. Now remember, algebraic simply means replacing numbers with symbols. I want you to think of everything you've learned about fractions. How to simplify them, multiply and divide them, and add and subtract them. And all we're going to be doing is applying our knowledge. By the end of this lesson, you will be able to factorize algebraic expressions. To begin this lesson, we need to recap the definition of factor. Remember, a factor is a number that divides exactly into another number. Think of the number 12. Do you know what its factors are? All you need to do is think of what numbers divide into 12 without a remainder. I hope you thought of 1, 2, 3, 4, 6, and 12. So what then is factorization? To factorize means to write a number as a product. Let me show you how to do this. You do remember how to multiply, don't you? What is 7 times 8? Well, we should know it's 56. So notice 56 is our product, and 7 and 8 are our factors. If we illustrate this in a diagram, you can see that the area of a rectangle with dimensions 8 centimeters and 7 centimeters is 56 centimeters squared. The length and the breadth of the rectangle represent the factors, and the area of the rectangle represents the product. So if I said to you factorize 56, your answer would be 7 times 8. So in writing 56 as a product of its factors, you have factorized it. Remember this, to factorize a number means to write the number as a product. Let's look at another simple example. What is A times B? A times B is AB. So over here, AB is our product, and A and B are our factors. So if we show this in a diagram of a rectangle, note again that the area of the rectangle is AB, this is the product, and the length and the breadth are B and A respectively. Now let's do another example. What do we get when we multiply A by A plus B? Well, to understand what to do here, let's first use numbers to help us multiply. Remember, A and B represent numbers. Let's think of our previous example where we knew what the answer was, so that it can help us understand this different approach. Think of A as 7 and A plus B as 8, because we know their product gives us 56. So, if A is 7, surely B must be 1. That means that here we have 7 times 7, which is 49 centimeters squared. And here we have 1 times 7, which is 7 centimeters squared. And to get the final answer, we add 49 and 7, and the answer is 56. Now we'll do the same thing a different way. We'll still work out the product of 7 and 8. But this time we'll work it out mathematically as the product of 7 and 7 plus 1. Now, 7 times 7 gives us 49. And 7 times 1 gives us 7. And when we add these together, we get 56. Now let's use this thinking to answer the question we have been asked. What do we get when we multiply A by A plus B? It will help us to use a diagram, and in this situation we are going to be using a rectangle. Now remember, the area of a rectangle is its length times its breadth, and we are going to be using this area as a helpful tool in multiplying. we'll use a rectangle with sides A and A plus B, and we are going to be working out the area. Now remember, this whole side is A plus B. And what we're going to be doing, just to make our lives easier, is split it up into two portions. This is going to be our portion A over here, and this is going to be our portion B. In other words, this is A units and this is B units. Now, what is the area of the square on the left? Well, we know the formula is length times breadth. So we're going to have A times A, which would give us A squared, and that would be the area of this square. And then we're going to have A times B, which would give us AB, and this would be the area of this rectangle. So altogether we have our total area, and our total area is going to equal A squared plus AB. Now focus on what we've just done. By using a known fact, namely to work out the area of a rectangle, we have shown that A multiplied by A plus B would give us A squared plus AB. Now what would happen if we tried to do the same multiplication algebraically? Well, let's write it. So we have A multiplied by A plus B. And what we need to do is multiply each term inside the bracket by our A. So we're going to have A times A, and we're going to get A squared. And then we're going to have A times B, and we get AB. And we should see we get the same answer. Obviously, we must get the same answer no matter what method we use. So let's summarize what we have found. The area represents the sum of the products A squared plus AB, and the sides represent the factors. Now, for more practice at factorizing, we're going to do the opposite of what we've just done. I'm going to give you the area of the rectangle, and you need to find the length of the two sides. Here I have a rectangle whose area is C plus BC. And I tell you that one of the sides has a length of C. What is the length of the other side? Once again, we can use the formula for area as a tool to help us. Let's look at the diagram and see what we have. We know that the area of this rectangle is divided into two parts, C and BC, which means we have two rectangles. So let's fill them in. The area of our first rectangle is C, and the area of this rectangle is BC. Now let's try and work out the sides. The area of this rectangle is C. So this side multiplied by this side gives us C. So what multiplied by C would give us the area C? The only thing that it could be is 1. So this side is 1. In a similar way, the area of this rectangle is BC. Now this length is also going to be C. So let's fill that in. And now we need to say what multiplied by C would end up giving us our area BC. And the only thing that can be is B. And we fill it in. And now we can work out the sides of our given rectangle. So the total length of this side is going to be 1 plus B. And let's fill it in. This length is 1 plus B. So the two sides of our rectangle are C and 1 plus B. What can we say about this? We can therefore say that the area represents the sum of the products, and the factors are C and 1 plus B. Now we can also see that we can write the product C plus BC as the product of C multiplied by 1 plus B. Notice that C is the common factor of C and BC. What have I done here? I have taken out the common factor c. In other words, I have factorized the expression. Let me show you what I mean in another example. Factorize a squared plus ab. Now a squared plus ab is an expression we have seen before. To factorize a squared plus ab without a diagram, we apply the opposite operation. In other words, instead of multiplication, we divide. Let's do it. Here we will divide each term by a. Why a? Because a is the common factor. A can divide into a squared as well as ab. So what are we doing? We say we are taking out the highest common factor. When we take out the common factor, we are dividing each term by the common factor. So in our brackets, we would have a squared divided by a plus ab divided by a, which means that this common factor is multiplied by the bracket. The factors of a squared plus ab are going to be a and a plus b. So we can write it as a multiplied by a plus b. Now I'd like you to take note of the following points on factorization. The expression a squared plus ab has two terms. Do you remember what a term is? In an expression, terms are always separated by a plus or a minus sign. In this example, the two terms are separated by a plus sign. This means that when you factorize a squared plus ab by taking out a common factor, there must be two terms in the bracket as well. Remember to always check your answers. You need to make sure that you have the same number of terms in your brackets as your original expression. So, up to now, we've been learning how to simplify and factorize algebraic expressions. Join me for the next lesson where we will be applying this knowledge to division and we'll learn how to cancel common factors.